Who doesn't love the moon? Without it, we wouldn't have romantic moonlit strolls or the ebb and flow of the tides. Worst of all, there wouldn't be werewolf stories. But even though it's our closest neighbor, there's still a lot we don't know about the moon. So let's talk about 3 of the most intriguing moon mysteries: its past magnetic field, the lunar sunrise, and what could be hidden inside its craters. Now, Earth's magnetic field is kind of a big deal. It helps us navigate, it deflects the sun's solar wind. Without it, we would be constantly barraged with charged particles, skin cancer would skyrocket, and the ozone layer would be toast. See, the Earth's outer core is a molten metallic fluid that contains electric charge. Those charges circulate around and create a magnetic field. Scientists call this the dynamo effect. For the longest time, we thought that the moon couldn't have had a magnetic field, but then Apollo astronauts brought home a bunch of moon rocks, and lots of them were magnetic. After analyzing these rocks and doing some computer simulations, we now think that the moon has a molten outer core and used to have its own magnetic field 4 billion years ago. What's more, it seems like the moon's magnetic field could have been even stronger than the Earth's and stuck around for way longer than we thought possible, for around 1 billion years. How? Well, that's the big mystery, but scientists have a few ideas. The moon used to be closer to the Earth than it is now, so maybe the moon wobbled or precessed so much back in the early days that its molten fluids started circulating. Or maybe the moon was pelted with so many asteroids it forced the fluids to slosh around. But one of the most promising ideas has to do with the internal layers of the moon blending. Thanks to the pull of the Earth's gravity, the molten core of the mantle might have rotated on different axes. If these layers weren't perfectly spherical, the molten fluids would have mixed around. As the Earth and moon moved apart, the gravitational pull weakened, and the angle between the axes of rotation would have decreased. No circulating fluids means no magnetic fields. But these are still hypotheses, and we need more modeling, especially from scientists who specialize in magnetic dynamos, to see how likely they are. Magnetism isn't the only mystery uncovered by Apollo astronauts. When they visited the moon, they saw a glow before the sun rose over the lunar horizon. The beauty of a sunrise might seem normal to us on Earth, but the moon has an incredibly thin atmosphere, which means fewer gases to scatter light. These astronauts saw a lunar sunrise with 3 parts: a low glow on the horizon, a glow that arced higher, and rays of light. Researchers think the horizon glow is dust being lit up, like when light shines into your bedroom and you see how badly you need to vacuum. The arcing glow is probably coronal and zodiacal light, sunlight scattering off of comet and asteroid dust in the inner solar system. Sometimes we see it here on Earth too. But those rays? We don't know. Our best guess is that the sun's radiation could be ionizing moon dust, and the charged dust particles might be repelling each other into the lunar sky. When sunlight hits those dust streams, hello rays. Understanding the rays could possibly be important for future moon colonies because charged dust wouldn't exactly be friendly to lots of electronic equipment. NASA wanted to solve this mystery with the LADEE mission in 2013 and 2014, but the spacecraft didn't find evidence of mysterious rays or dust fountains. So for now, all we can do is guess. Our third mystery isn't in the sky, but hidden deep inside the moon's craters. Craters are sheltered and cooler than the surface, so there's a lot we could find, like water ice, different kinds of rocks, or even possibly signs of past life. See, the early solar system was downright violent. Around 4 billion years ago, when the Earth and Moon were young and being pelted with asteroids, they would have swapped a lot of rock. This might have been when life was first forming on Earth. It wasn't very flashy life, we're talking about single-celled prokaryotes, but what they lacked in looks, they made up for in toughness. Earth had a lot of volcanic activity and an atmosphere that would be toxic to most life today. Most scientists consider this a long shot, but if any of these microbes ended up on a chunk of Earth that crashed into the moon, they might have been buried in a crater. All the rocks on Earth this old have been destroyed or reshaped, so we don't have any records of this period on our planet. The moon's craters, though, could give us a glimpse of that period of our history, and even let astrobiologists know where they might find life on other planets and moons. We won't know for sure until we go digging for samples, either with robots or with good old-fashioned shovels. Any volunteers? So our solar system is full of interesting things to explore, and everyone is really hyped about getting to Mars right now. But since we still don't understand everything about the moon, maybe we should take a look closer to home. Thanks for watching this episode of SciShow Space, and especially to our patrons on Patreon. Right now, we are doing something a little bit different on Patreon. Until the end of the year, we're going to be taking all of the money that we raise on Patreon and putting it toward a brand new show. The 3 choices for the new channel are SciShow Life, SciShow Psych, and SciShow Health. health. If you're interested in any of those ideas, Patreon patrons are going to be deciding which of these becomes its own channel. Of course, if you're not interested in any of that, thank you for watching all the same, and don't forget to go to youtube.com/SciShowSpace and subscribe.
Fully loaded with fuel, the Saturn V was over 100 meters tall and weighed almost 3 million kilograms. That's 15 times as much as a blue whale. The rocket worked in 3